In this video, we'll be going over remove linked list elements. So given the head of a linked list and an integer val, remove all of the nodes of the linked list where the node value is equal to val, and then return the new head. In our first example, we're given this list, and then we want to remove all of the nodes that's equal to val, which is currently 6. So we want to remove all of the nodes with the value of 6 to get this output list. Let's go over the dot process. So for each of the node x inside the input list, we will first want to disconnect x. But before we disconnect x, we should save the next node. This will allow us to move forward after we have processed the current node. Now if x.val is not equal to val, then we can append x to our resulting list. So we're going to create a sentinel node. We're going to create the following variables. We'll first have a sentinel node, so the sentinel head node, which will be the head before our resulting list, or the head of our resulting list. Then we'll have a sentinel tail, which is the current tail of the resulting list. And then we also have a node, our current position, initially head, and then while node is not equal to null, we want to disconnect the current node. But before we disconnect the current node, we want to save the next node. So we're going to create a variable next and set it to node.next, and then we want to disconnect the current node. Now if node.val is not equal to val, this means we can append the current node to our resulting list. So I want to set stail.next to node, and I want to set stail to node. Then I want to move the current node forward. Then we can return the sentinel head.next. The sentinel tail will be initially sentinel head. Now let's go over the time and space complexity. For the time complexity, we get O of n, where n is the number of nodes. We visit each node once, and our space complexity, we get O of 1. Now let's go over the code. So we're going to create the 3 variables. The first one is the sentinel head. And then we have a sentinel tail, which initially points ahead. And then we also have a node, which initially points at the input head. And then while node is not equal to null, we want to disconnect the current node. But before we do that, we want to save the next node. And then we disconnect the current node. And then if node.val is not equal to val, this means we can append it to our resulting list. Then we want to move our pointer forward to the next node, and then we can return the resulting head, or the head of the resulting list. Let me know if any questions in the comment section below. Like and subscribe for more videos that will help you pass the technical interview.